So, on stage we have Wilhelm or Will, and you have also made a trip, quite a trip here to Copenhagen, and it's your first time, I understand.
Yeah, second time in Copenhagen.
Second time.
But I'm always impressed by how friendly everyone is, and all the bikes. Love the bikes.
Thank you. We're swimming in them.
Yeah, do bikes get stolen in Copenhagen? It seems like there's so many, like...
Yes, and you're going to tell us about Kolo, and that's probably something that's new to a lot of people in the room without working directly with Kolo. Has anyone heard of Kolo before? Aha.
Oh, there's a few folks. Yeah, nice.
Yeah. And really excited to have you contributing this. So a big hand for Will.
Yeah, thank you so much, Ben. Yeah, really excited to be here and talk to you all. Like we were talking about earlier, excited to be back in person at these events and get some interactions and meet space. So yeah, I'm really been looking forward to this. So I want to talk a little bit about Kolo, which is something we've been building, but I'm actually quite curious to explain a little bit where we're coming from with this. What's the problem we're actually trying to solve, and why is it useful to understand everything that your Django app is doing at runtime? So a little bit about me. I've had most of my experience working with Django with Simple Pol. I've been using Django for about 8 years now. So that's about version 1.7 is the first Django version I use. So I kind of grew up with migrations already in Django and have learned to appreciate that. And it's been mostly for building Simple Pol. So Simple Pol is an app in Slack. If you've used Slack, it's very possible you've come across Simple Pol. It's one of the most popular apps in Slack. Millions of users using it. And that's the most sort of the context I've been using Django in. And then I did spend a few years working at GitHub, which has a huge Rails app. So I have a couple of strong opinions about things where Rails is just much worse than Django, but also a couple places where I think Rails is really good, actually, and Django can learn some things from that. So if that's something that interests you, hit me up. I'd love to talk about that more. So where does that lead us? So I wanted to kind of start a little bit with this picture, because often when I'm writing code, I feel like I'm in this picture. I feel like I'm that guy. I'm kind of like rubbing my hands together, trying to make fire happen. It feels a little bit like it can be so slow to create new software. It feels like we're still in the Stone Age, and there's so much more we can do. But it just feels slow often, and yeah, clearly we've evolved to make fire happen much more quickly. I think we can do a lot to also, make software creation happen a lot more quickly. It's very interesting to me. And one of the times I felt most when, like I was in this situation, is when I was adding a new feature in GitHub. So this was at the time when I was working in the GitHub Rails code base, and it was my task to add a feature to show these CI failures on the files changed tab in the pull request on GitHub. And it's quite interesting because I always think of one of the main features that GitHub provides is this collaboration on the code that changed, the collaboration on the pull request, and diffs, essentially. But as you can imagine, this code is actually, there's a lot going on. It's been around for like over a decade. Hundreds of engineers have touched GitHub's sort of internal representation of diffs. So I have a diff here. So this is just git diff, right? GitHub isn't involved here, but every single like character that you can see here, like these pluses, these @ symbols, this is all modeled like extensively inside this massive Rails code base. There might be like 20 different methods that just talk about like this number, right? So like that's kind of the complexity. So there's hundreds and hundreds of functions, lots of indirection, and now it's my job to add this new feature into this like huge amount of complexity. And you read this code and there's all these anti-patterns. You're like, why are we doing it this way? And then it's just a comment that says, well, like we tried all the different approaches and this is the fastest. Like that's why it works this way. And you're just like, damn, like all my mental models are falling apart. Like how do I do anything here? All these edge cases that get handled for problems you didn't even know existed. So it's a huge amount of complexity. So, and that's kind of what led to Kolo. But before we go deeper into that, that was essentially the problem I had. But here's the structure of this talk. So first of all, talking a little bit more about the problems with reading and understanding code, inspecting runtime data as maybe a solution to some of those problems, and speeding up how quickly we can read and understand code. Then, most excited for this one, I'm going to give you a demo of Kolo, the tool we've been working on, and just give you an understanding of what it can do today. And then also, I'd love to end on this note, depending on how much time we'll have, this glorious future where we can collect, inspect, visualize what our code is actually doing, and how that can be a really useful tool for us. And I'd love to continue the discussion with you also after the talk. I'm sure many of you will have some thoughts. So let's get started with the problems with reading and understanding code. So the thing that's kind of really interesting here is that I think from an outsider looking at our profession of software development, the output that we create is new code written, right? That's kind of the work product of what we do. You might see someone write 100 lines of code in a day, and that's their productivity for the day. But in creating code, there's this interesting dynamic where actually we read a lot more code than we write. So there's this ratio that for every single line of code that you write, first you have to read and understand 10 different lines of code, which I think is kind of interesting because we have all of this extensive tooling to help us write code. But it feels like there's not quite as much, or maybe the tools aren't quite as good for really reading and understanding existing code. Like, yeah, it feels like the dynamic is a little bit off there. And I think at this point you might say, well, but I feel like at some point, I know my code base, I've read and understood the code. So I want to make the case a little bit that it's actually quite a common thing that you have to understand new code that you haven't come across before. So the first one here, onboarding onto new or unfamiliar code, I think is quite a common scenario, not just when you join a team or join a new company and you kind of have to ramp up on that, but I think as soon as you work in a team context where there's other developers working with you, you might be on vacation for 2 weeks, and while you were away, your colleagues were busy shipping, merging, reviewing code, and now that code is kind of new to you. Even if you have reviewed code and kind of were very sort of intimate in the process of getting that into the code base, it might still be not at the level of understanding for you like it is for the author. So I think, yeah, it's just I think as soon as you work in a team, you're essentially constantly onboarding onto new or unfamiliar code. There's a couple other ones. Yeah, like I was saying, this was my case, understanding where can I where can I insert a new feature that I had to onboard onto a lot of new and unfamiliar code there. I think there's also this interesting thing where something happens during a request that our Django app is processing. And maybe we can see some SQL query logging on the database side, and we know that this really big, expensive query is getting made. Or we use something like Django debug toolbar, and we know this big, expensive query is getting made, but we just don't know where. So we have to ask this question, like, what's happening? Like, where is this happening? And then I think this last one can be pretty painful as well. This might either be, if your application is deployed in production, or even if you're just playing around locally. Sometimes our code the code execution can reach a point where it should never be able to go there. Like maybe you even look at the code and it says like, this should not be possible, or like if we got here, something went terribly wrong. But the problem is you did get there, and now you're asking yourself like, what the fuck's happening? So this is exactly what was happening to me. I think even day to day now, like working on the simple pull code base, it's interesting because I wrote a lot of that code, but since there is a lot of it, there might be a feature I haven't touched in like years or at least months, and I'm coming back to it, and I think, wow, what's going on here? Like it kind of has to. It's almost like there's this RAM that exists in my brain, and I first need to like spend 4 or 5 hours like getting all of this logic and these models and how it all works together like into my RAM, and then I can kind of work with it. But fortunately, after 5 hours, the workday's over and you start again the next day. Or worse, you get interrupted and and then you have to kind of keep starting, and it can be very frustrating. So I think this is interesting. I mean, I feel like this will be a familiar problem to you, that you just need these long blocks of focus time. I think it's a really interesting question to ask, like, what if you only needed like 30 minutes or an hour to ramp up on code, and then you could be really productive? I think, as an industry, I think we could become a lot more productive. It could be a lot more fun, I think, as well. And I think what's interesting is that a big part of like this idea of the RAM and how you have to initialize your own RAM on unfamiliar code is that we really rely on imagination quite a bit. So we ourselves imagine how code executes, and that's kind of how we build our mental models. So we're kind of pretending to be a computer a little bit. And again, if we kind of look at our editor, we have all this colorful text and beautiful syntax highlighting and jump to definition, but we're still manually executing what the code does, or what we think the code does, which the computer can help us with that. Now, you might say tests. We have tests, and I think yes, tests are great. Tests can be super useful, but I think unfortunately imagine it again. If you're like coming onto an unfamiliar code base as a new developer, you kind of need to know about the tests in order for them to help you. Like, yes, the tests might help you verify that something works a certain way, but if you don't know which tests relate to the code you're looking at, you're kind of back to the starting point. Like, what's happening? What test is what test could possibly help me with this? And well, then you might say debuggers. We have debuggers, and debuggers are great. I love putting print statements everywhere. I love breakpoints. I love everything built in. I think the unfortunate thing, or the problem I have with debuggers, is that I feel like it's really easy to get to a place where I don't really want to be, especially when I use these bottoms to like a built-in IDE debugger or breakpoint. I just hit the wrong character. I hit like S or something, or maybe it was intentional and I try to step into a function, but then I've hit enter a few more times and suddenly I'm deep in some library code that I don't recognize. And I'm like, how do I go back? Where's the undo button? And then I just hit Control-C and exit and start over, and it feels like not the greatest experience. So yeah, it's a bit too easy to get to where place I don't want to be, and it can be frustrating. So yeah, I think there's a couple of problems with debuggers, and we can talk about all of them. I think the biggest problem is with debuggers is they just ask quite a lot of you. And I think the biggest thing that they ask of you is where to start. Like, where do I put my print statement? Where do I put my breakpoint? Like, that's the point. Like, you don't know where. Like, why are you asking this of me, debugger? Like, why are you not helpful here? So I think often what I do, what a lot of people do, is you set the breakpoint somewhere. You try, it doesn't work, you repeat. Maybe you even set 10 breakpoints, 20 breakpoints, and you hope one of them gets hit. But it feels a little bit like we're kind of flying blind. So I think that's the biggest problem with debuggers. I think they're super useful, like if you already have a pretty clear idea of what you're looking at. If you don't have that very clear idea, I think it's less helpful. And then I think the other problem that's quite substantial is that you get this kind of local point-in-time overview. And I think this is pretty helpful, pausing your program and poking around like what's happening at this point in time. But it's not too helpful if you want to build up a more kind of a global, high-level overview of what your code is doing. If you want to do that, debuggers can give you the sort of pieces, the dots, but then you have to connect the dots. Debugger doesn't really help much with that. And so what are the tools that we have for this for dealing with this problem today of getting a high-level overview, onboarding onto unfamiliar code? I think these are the tools. I think first and foremost we have a team. We work in teams. Often, sometimes we don't. But colleagues, they can pair with us. They can give us context. Maybe they even wrote some documentation, and that can help us kind of get familiar. And I think that's great. This middle one might be a bit unusual, but when I had this problem of working with diffs at GitHub, I came very close to just printing off all the code and putting it all over my walls and just annotating, okay, this function goes here and then this goes there and then this loop gets called 100 times. I think it can actually be quite useful just so that you can scribble all over the code. But yeah, it feels like it shouldn't be the best tool. And then I kind of already mentioned this. We have our brain, right? Our brain is pretty powerful. So I want to talk a little bit more about that for a second here. So I think this is interesting because our brain does this stuff, right? So our brain, we kind of see what's happening, we see the dots, we look at the breakpoints, we inspect the data, we process all this information. in our brain, we kind of simulate what's going on. We try out these different conditions and branches, and then we filter out what's most interesting. We have like this mental model, and then maybe we draw some conclusion. Does this feel like very similar to what a computer is good at? Like processing lots of information, simulating lots of different branches, filtering. Feel like computers are good at a lot of these things. Like why don't we let them help us a bit more? I think it's worth pointing out though that using our brain, using Teams, using a printer, if you feel it's helpful, it does work. But I think the problem is it's slow. So our brains are powerful, but it just takes time to build an extensive mental model. But I've worked with some really productive colleagues who usually have spent months or years working around the code, the code base that I'm interested in, and they're able to be really effective because they need less time to get their own RAM set up. They maybe have something loaded into like a very fast SSD or something that they can pull from, and they have all this state in their head, and that allows them to just reason and reason about it much more quickly. But the problem is that it does take time for these mental models to build. It's kind of one step at a time. You might start somewhere, you start poking at the code, you make a mistake, maybe even break something in production. All of this helps with our learning, but it does just take time. And I think it'd be great if we could reduce onboarding onto a new code base from 3 months, 6 months to a week or an afternoon. Wouldn't that be fantastic? But yeah, so what do we do about all of this now that I've painted a terrible state of the world and talked about all of our problems? Well, I think there's this interesting idea of inspecting kind of what is actually happening at runtime, and Python provides some really great hooks for this. If you're curious about how Kolo works under the hood, Ian is in the audience, so hit up Ian. He's sitting right here at the front, and we can talk more about that in depth. It's all pretty interesting. But yeah, this idea of looking at what our program is actually doing. And this isn't necessarily a new thing. Like the technologies kind of exist here. So you might have seen some of these. I think actually Sentry, Datadog were mentioned earlier. These tools already look at least what part of our code is doing and then extracting that information. So some of this question of what happened or what's going on can be answered with these tools. What I think is interesting though is actually, let me show you this. So yeah, so this is what it looks like, right? So this is what Datadog. This is a trace of simple poll in Datadog. It took like 300 milliseconds. There's a bunch of SQL queries. Then it ended with a request. Like this is helpful in giving us an understanding, like where in a given request that's served by the simple poll Django app. What's going on? Like, okay, there's these middlewares, and then there's these SQL queries, and then there's a request to the Slack API. Like this is helpful. But these tools are largely built for monitoring, performance, profiling, and these very clear cases of there is an error, there is a problem. This is helpful if you want to find a solution to this specific problem. But I think what I want to talk about and what I find quite interesting is this focus on understanding. Like very few, really very few tools focus on helping you understand what your code is doing at a more global, high-level perspective. Not how do I solve the specific problem, how do I optimize the performance in this specific thing, but hey, help me understand like what my code is doing. Help me, create my mental model for all of these things that are going on and that I can then use to be more effective. All right, so this has all been pretty high level so far. I think a lot of this applies broadly to software development or broadly to web development. But I'm going to simplify this a little bit for us and make this all just a little bit more tangible. So we're going to talk about Python, and specifically we're going to talk about Django. This is the Django day after all. And finally, we're actually not even going to talk about all of Django, but just about the HTTP request response cycle. And HTTP is actually a great gift, because it's this beautiful stateless protocol that helps us reason about just a part of what our code is actually doing. So a request comes in, we serve a response, some code was executed in the middle. We actually don't need to understand everything at once. We just need to kind of understand what happened here. what's or over several requests, what happened in all of these. It's great because we can understand and learn sort of one step at a time. We don't need to know about everything that our code base is doing. We just need to take it one step at a time. So I think HTTP is incredibly useful. Okay, so this is where we get to the demo of Kolo. Before we get to it, I guess a few words just to kind of introduce it. So the best way to think about Kolo, it's a tool that helps you understand what your code is doing. And the way it does that is really two parts. So on the Python side, it's a middleware, so you can pip install Kolo and then add it to your middleware list. And then the other piece is a VS Code extension. So the middleware runs, inspects your code, collects all this information as your locally running Django app is serving requests. It saves that all into like a SQLite database, and then it's displayed and served up in the VS Code extension for you to get insights from. All right, so now we are going to look at the demo. Let's see how quickly I can switch this over. All right. Sweet. That wasn't the most painful thing in the world. All right, you can all see this. I guess it's quite small. This is quite big now. All right, so just to kind of set the scene here a little bit. So what we have here is VS Code on the right, and then we have Slack running on the left. So I'm going to use Simple Poll as kind of a demo case for how we use Kolo. In many ways, Kolo is kind of an internal tool to help us build Simple Poll more quickly. So what I actually am going to do is do something in Simple Poll, interact with Simple Poll. You interact with Simple Poll via Slack. And then what I'd like you to do is to look at this list of requests. So if you're unfamiliar with VS Code, you have all kind of these tabs here on the side. So you have the File Explorer, and you have Search, and you have Git. And then Kolo is here, and the kind of the main way Kolo works is by showing you a list of requests that the locally running Django app recently served. So I have Django running down here. Get rid of that. And then it shows you kind of historically the most recent requests. The most recent one is at the top. So I'd like you to pay attention essentially to that list of requests, because as I interact with Simple Poll, my locally running Simple Poll, you can kind of see additional requests show up here, right? So I just asked, hey, please, I want to create a poll that fired off a request to my local Simple Poll to serve up this modal which opened. And let me ask a question. So creating a poll which has really one option. Let's be real. And then let me create the poll. So this created the poll, and now I can even cast a vote on it. And you can see all of the requests sort of coming in live as this is happening. So I'm going to get rid of Slack now, and we can kind of focus on just Kolo. So yeah, like I said, you kind of starting to get the idea that we have these recent requests that went to our local Django app, and like Kolo is kind of displaying them all. One interesting thing that might be different in your Django apps is that the way the Slack API works, they all kind of arrive at the same URL. I think this is common if you have like a GraphQL API, you have different queries going to the same place. If you're processing webhooks from any place, maybe if you have payments in your app and you have a payments provider like Stripe, they will typically send all of the webhooks to a single URL, and then they all arrive in one place. Now, this can be pretty unhelpful if you're then trying to debug these requests. So one of the things Kolo helpfully provides is this custom request description. So you can kind of see in gray. It gives us a little bit of a better sense of what this request actually is. So we have a little bit more to work with, rather than just the path and the method and the outcome. All right, so let's dig into one of these. I want to dig into the poll that was created. So let's look at this one. So for each of these, you kind of get an overview of all the different basics. There's a lot of stuff that you'd expect. When was this? How long did it take, etc. The thing that I think is really interesting is we kind of give you all of the frames. So what a frame is kind of like the language from the Python internals, but you can kind of think of this as like every function that was executed during this request, all of your code that actually ran during the request. So we can go into one of these. What would be interesting? Maybe we go into this one. So this takes us straight to our code. Now, usually on your screens, I think you'd be able to see a little bit more here. Maybe I can zoom out one, and it would still be slightly visible. Is that all right? Can you kind of see that? Okay. So we know that this function was hit, and actually Kolo provides these inline annotations that tell us, okay, this function was called with these variables. And then later down, we can also see here's the where it returned. So for this specific trace, for this specific poll creation request, here's exactly which code was executed. And of course, you can kind of click on these. Let me go on to the return one. And you can see all of the locals that were available. So this is all of the input arguments. So this is exactly all of the data that was passed in here from Slack. All of these different pieces of information we have access to. So the Slack user, the Slack team ID, et cetera, et cetera. And then here's all the locals that were defined. And then finally, here's what the return value was. So in this case, we return a JSON response from Django. So for every single function that was executed during the request, we have access to this information. So the thing I want to highlight here, and which brings us back to kind of the problems I was talking about, is if I'm a new developer on the SimplePoll code base, I don't need to know about all of this code to start, or all of these files, which functions, to start understanding like what's happening, what's going on. All I need to have running is a local version of SimplePoll, and I need to just start interacting with it. As soon as I start interacting with it, I can start understanding, okay, this interaction leads to this function with this data. So this is what Kolo gives us access to here. Of course, let me close this real quick. We have the frames. We also have access to the SQL queries. So we can look at all of the different SQL queries that ran, that Django wrote for us and sent to the database. And then crucially, we can also see where they were made from. So this is a little bit small here. Maybe I do zoom in again. This is a little bit small here, but so every single SQL query, it tells us where exactly in our code was this query made. So this is making a request to user. It does a bunch of stuff, annotates. But Kolo helps tell us, where is this coming from? So if we were, curious about, what the hell this query is taking forever, 37 milliseconds, and it's duplicated. Why? Like, where is it coming from? We can jump straight to where in our code that query actually comes from, which is super handy. Now, this might not be relevant for all of you, but in the case of SimplePoll, much of what we do is actually send API requests back to Slack. And I think typically outbound HTTP requests tend to, are quite interesting. So Kolo includes those as well. So we can see here, okay, we made, in this case, this would be telling Slack, hey, please post this poll in Slack. So here's exactly the HTTP request that we sent back to Slack to create the poll. So if something looks off in the output that we maybe as a new developer observe in Slack in the actual output, we can immediately go back to exactly the request that we sent and kind of find the corresponding bit and then work our way back from there. And we can also see what Slack returned, which in this case is a very helpful. Okay, true. All right, so, but believe it or not, I think this is actually not the most interesting bit of Kolo. So the coolest part of Kolo, in my humble opinion, is the frame visualization. So can I zoom this out? Let me recreate this. Okay, we can see a bit more here. So kind of a reminder, again, this is this is the request to complete creating a poll in Slack. And this is what it looks like. So every node you can see in this graph is essentially a function call. So I can hover over these and see this is where it kind of started, this poll action that returned that JSON response. But kind of we can get an overview about everything that's kind of going on in the course of the request. The white nodes are just your code, your function calls in your code. Then the green ones, so this one, for example, is the beginning of a celery background task. So everything that comes after here is happening in a background task. And same thing here. We kind of start a background task, and then all of that happens afterwards. The blue lines are an HTTP request. So this would be the place where we then actually make the request to post in Slack. And then newly available and not yet released, the purple lines are all of the SQL queries that get made. So you can kind of starting kind of from nothing, you can get an understanding of here's everything that's happening, everything important that's happening during this request. You can see kind of where do the most SQL queries get made, where are the background jobs starting. One thing I've noticed and I found incredibly useful actually is at least the way kind of our code seems to be mostly structured, is that there's always a bunch of stuff going on and a bunch of kind of checks here at the beginning. Is this routing? Is this user allowed to do this thing? But then there tends to be this one main blob, which kind of coordinates most of the work. In this case, we actually have two. So we have this one here, complete poll creation. And we can obviously jump straight there and then go and explore all of that. And then we have the second one here, which is the background job to kind of post it in Slack. So we get kind of an overview of everything that's going on. We can jump to the SQL queries. We can jump to the HTTP requests. And then also you can see down here, we have a flame graph. So this visualization at the top, it kind of gives us a bit of a spatial layout. Like, what are all these things that are going on? Which function seems to coordinate the most work? And then, yeah, like I said, this tends to be a good heuristic for me when I'm refamiliarizing myself with something. This is where do I need to go to like make my change? Well, the function that coordinates it is kind of a good place to start looking and then refamiliarize myself with all that's going here. And often I tend to add whatever new feature it is in one of these functions that coordinate a lot of work. This would be another example here, post creation logic. But yeah, then we also have the flame graph down here, so we can kind of explore a little bit what's taking the most time. And obviously, especially with the internet here, it seems like the HTTP requests to Slack are taking, almost a full second down here. But you can also dig in and zoom in and see, okay, interesting. So just saving the poll, that's a couple of requests, here and there. But yeah, going back to this idea of understanding, you just start to build a picture with all of these various tools, either at the very specific level or at more of the global high-level level about what's actually going on in the code. You can start kind of from zero. Now, I want to show one more feature, which is also unreleased. Actually, might be released, but it's hidden. So imagine again, you're sort of new to the code base and you're investigating and you're trying to figure out what does this function do here, right? So yeah, I mean, I'm not expecting you all to kind of understand this right now, but this is a function, is standard emoji for action ID. What does this function actually do? It looks simple enough, but it's a little bit weird. And you can look at the example here. Let's take a look at this, and we can see that it was called, the input arguments were ID1 and then emoji1, and then it just returns true. Okay, interesting. But what about when this function doesn't return true, when it returns false? Like, what would need to happen so that this function would return false? Well, what we actually can do by just recording all of these traces over time is we can show you not just information from a single trace, like a poll getting created, but we can also show you, any examples we have of this function getting called. So if I hover over this, I see here that Kolo has actually 74 examples for us of how this function is used in practice across all of the locally served requests. And fun fact, you actually can enable Kolo in your tests as well by setting the debug mode flag. Kolo runs only when debug is true. In tests, by default, debug is false. But if you pass that flag, then Kolo will run for your tests. which can be a great way to kind of seed your database with all of these different examples, especially if you have great code coverage. So I'm just going to click on these examples here, and that opens up another kind of tab with many different examples of how this function is called in practice. Now, again, this is still not very helpful because we get past 1 and then it returns true. But what I can do here now is I can search for return false. And now, interesting, we see something here. So we see action ID 4, and then the emoji is pizza. Now, that is kind of breaks the pattern. We always see 3 and 3, 5 and 5, and now here we see 4 and pizza. So now this might be obvious if you're, if you wrote the code. I wrote this code. It might be obvious by reading the function closely, but it's just so helpful to see like an actual example. Like when would it not be 2 and 2? When would it not be 5 and 5? Well, it turns out you can have 4 and pizza, and that's when this function would return false. And that's now strengthened your mental model a little bit and kind of got you a little further on that journey of understanding. All right, so I am now going to go back to the last slide and talk a little bit about the glorious future of inspecting our code at runtime. All right. Where are the slides? Slides are gone. So while I get this back up, I think essentially what I want to say with this is, I think some of these explorations with Kolo are, oh crap. There we go. So, oh, now I'm at the beginning. Oops. So yeah, what does this glorious future of inspecting our code at runtime actually look like?
You need to share your screen again. Sorry.
Oh, is it not working?
Yeah, you just down here. And share screen. Okay, and then that one over there.
Perfect.
And share.
Lovely. Is it working?
Perfect. Thank you. Great.
Yeah, okay. My notes aren't working anymore. Anyway, so yeah, this idea of like, what does the future look like where we can look at our runtime data in this kind of way? Like, so I think some of these things that Kolo can do are interesting, but I think there's so much more. If you imagine like sort of a storage layer that's always available to any running code, I think there's so many more interesting things that we could do. Like, could we share some of these traces with our team, and then we all have access to the same underlying database, and you don't even have to run tests to locally seed your examples. You just have them available immediately from the day you open your laptop as a new joiner. Or could something like Kolo run as part of CI and tell us, hey, your code looks great in your pull request, but actually you're adding like 2 SQL queries to every single existing test in the code base. Like, are you sure you want to do that? Like, it slows things down. Like, it's surprising to me we don't have some of this tooling already, but I think it becomes possible if we keep track of what our code is actually doing. And staying in the world of tests, these examples for functions, I think they could actually become great unit tests. We can take some of that data we collected at runtime and turn it into tests, and then have that run automatically for us. Or even beyond unit tests. I think one of the things that I actually enjoy least about software development is writing tests. Like, I enjoy, this is controversial, but like, I enjoy building the thing and the feature and making it happen. And then, afterwards I come back and now I have to like do everything again, write the test. And it's not even the assertions. Writing assertions and tests are fine. What I find annoying is the fixture setup. Getting all of the stuff in there and then making sure the test client has the same request that I was already doing anyway locally, and then writing the assertions is fine. But yeah, the fixtures is kind of what I find annoying. But I think we are basically already collecting the fixture data by running Kolo. So is there a way we can perhaps just save that data into a test and have that be a starting point for then you to write your assertions? So I think that's a couple of ideas. I think there's actually many, many more. I'm really curious what you all think, in questions or even discussions later today or virtually. I think, yeah, there's a lot we can do here, and I'm really excited for what this glorious future could look like. And then last slide. So if you want to use Kolo, Kolo.app is the best place to get started. We are also on Discord. That's a great place to chat and have some of these discussions. Kolo.app/Discord. If you want to email me, Wilhelm@Kolo.app is a great place to look. We are actually looking for someone to join us part-time on Kolo on Mondays and Tuesdays to actually work on kind of the front end, the VS Code side, the TypeScript side. So if you have experience with TypeScript, front end, and also Python, and you want to do 2 days a week, then, or if you know someone like that, please come talk to me. As I said, Ian is in the audience to talk about how Kolo actually works. And then also Kez and Jakob are here, who are on the Simple Poll team with me. So there's a couple of us here. I'm sure we'll get to know you all throughout the day and later. But yeah, thanks so much for your time. Great to be here with all of you. And yeah, looking forward to the discussion.
Super nice, Will. Right on time.
Love it.
But we do, and right on time, as in we do have time for questions.
Yeah. Awesome.
I do have one little clarifying question,
Yep.
if I may start.
Yeah.
Kolo is running as together with the Django dev server locally on the laptop right now.
Yeah, exactly.
Okay.
Yep.
And you're looking to expand that into multiple.
Yeah, it's
dev
interesting.
servers?
You mean like running online or in
staging
production?
in production
Yeah.
and so on?
Yeah, I think staging could be pretty interesting. I know actually we've had this come up recently internally for us. We'd love like if it was available in more places. I think it's local for now because it allows kind of the most room for experimentation. So we are still in beta. So I wouldn't recommend running it in production, but it's pretty safe to do locally, right? Like all it does is save some files locally for you, and then if something ever was to break, just comment it out, and then everything is working again. Whereas in production, it'd be a bit more serious. I think like over time, like we could go to these other environments. I think CI actually is, I think is quite interesting, and maybe similarly safe as opposed to all the way to production. But yeah, I think it's quite interesting, but it might take a few years before we get to production.
Hopefully faster.
Yeah.
There is also a number of questions, sort of the same category as Jo is asking if there is a plan to have an extension for the other editors, those that are not Visual Code. Will you be able to do that at some point? Do you have Kolo running like separately so you can build another IDE integration?
Yeah, exactly. Yeah, no, absolutely. So the architecture definitely supports it. It's really like a nice kind of front-end, back-end separation. So everything is saved in like a local SQLite file. Like you can find the SQLite file, look at it. If you love writing SQL queries, you can, you can get the data yourself. And even if you're, say, using Vim, you can start like querying that SQLite file and get the data that you're looking for. It'll be a bit harder. But yeah, the architecture definitely supports other extensions. Like I think PyCharm is a very common request. I feel like if we were to build another one, that would probably be the first one. But I think even on the web could be quite interesting. Like having kind of a web solution so that you could look at the Kolo's output without needing to be on a specific IDE. For context, like right now, the focus has definitely been to make this part of your development experience as much as possible, reduce the amount of context switching. Like you could see the whole demo was inside VS Code, like jumping around various functions, opening up these files. It's intentionally built that way so that it can become part of your workflow, as opposed to adding another window or another kind of tab onto it. So that's important. I think actually what we might do is VS Code can actually run in the browser. So we might build it in such a way that you can just see Kolo's output on your code base with VS Code in the browser. Like that's not as great as having it perfectly natively in PyCharm, but it might be a good workaround like in the meantime. It's definitely a lot of work to build another extension. So yeah, it'll happen at some point, I'm sure.
Mm-hmm. Any questions from the audience? Yes?
What's the overhead on running this? Like you talk about enabling on a test suite. I've got a test suite that runs for 10 or 15 minutes or something, and I enable it for this. How long is it going to run for?
Yeah, great question. Yeah, I think like, it's interesting. It definitely varies on what you do and how much work Kolo does. I think for the most use cases, I'd probably recommend just using it on a single test, or maybe on like a small app, like a Django app, and just populating it there. I think if your test suite is already 15 minutes, then yeah, we're not going to make it any faster. I think it's in kind of local development. So when you're processing one request at a time, the overhead is pretty negligible. So you might go from 600 millisecond request to like 800 milliseconds, which for a single, like that's a substantial percentage increase, but for yourself, it's not noticeable. I think, if we want to do a good job at the full test suite, it's going to have to become faster than it is right now. So there's some overhead, but there's also paths to reducing it if the test suite use case becomes like very interesting.
If I'm only doing that to seed your database, that's in a SQL file locally, then
Yep.
I need to do that once anyway.
Yeah, exactly. You just need to do it once. Yeah.
There's one more question. I think we can make it the last question before we go to the lunch break.
Sure. Yeah.
Like a quick one. Yep.
So I've been using Kolo, and at the same time, I'm trying to use sometimes Django debug toolbar.
Oh yeah.
It's a bit of a weird interaction because sort of responsiveness really goes down the drain when that happens. Do you happen to know why, or? Yeah,
good question. Yeah, we need to look into that. I think
something that can be fixed.
Yeah. So you're saying when you have both Kolo and debug toolbar, it adds a lot of overhead.
Yeah, like a half-second request turns into a 10-second request sometimes or something.
Really? And when it's just Kolo, that doesn't happen. And when it's just debug toolbar, it doesn't.
When it's debug toolbar seems to have a lower sort of response time than Kolo. It's debug toolbar is worse than Kolo when you're trying to get
right.
Bigger.
Yeah. I guess a related question is how do we post feedback for Kolo when you're running the beta?
Yeah, absolutely. I think the best part is in the GitHub repository. So opening a new issue there. I think the Discord is also a fine place to start. But yeah, clearly there's some interesting things we can look into there. Ian's actually been working on performance for the last several months, trying out various bits with Python, which is kind of new to me and very interesting. But yeah, like the interaction with debug toolbar specifically seems like it's making things worse. So yeah, I'm curious. Maybe we could do something there,
Yeah. I'm sorry it has to be the last question, but give Will a big round of applause.
Thank you.